Hello everyone, welcome to Engineering Archives. Let us look at the first learning problem for the chapter dot product. This question says, determine the angle theta between the force and the line AO. So they want us to find the angle theta. So in order to proceed with the solution for this question, we will be using one of the formulas that we discussed in the previous video. So the formula that we will be using is formula number 2. So let's go ahead and write down this formula with our question. So the formula says that the product of two vectors, the dot product of two vectors is equal to the product of their magnitudes multiplied by cos of the angle between the two vectors. There is another way to write down this formula as well, and that new form will make it more easier for us to solve this question. If we divide the product of magnitude of both vectors on both sides, we get the following form. Notice that this is equivalent to this. And now we come to see that these are just the unit vectors in direction of the A vector and the B vector. So we can write these as the unit vector A dot product with the unit vector B. And this is all equal to cos of theta. So this is the new form for this formula that we will be using for this question. So first of all, we need the unit vector in direction of the force vector F. So let's do that. They have given us the Cartesian form of the force vector, that is negative 6i plus 9j plus 3k. We can find the magnitude of this force vector by using the magnitude formula. And the magnitude that we get is 11.22. Now using this magnitude, we can find the unit vector in direction of the force vector F by dividing the force vector by its magnitude. And we end up with the following unit vector. Negative 0.5345i plus 0.8018j plus 0.2642678k. Alright, now that we have our first unit vector, we can proceed and find the next unit vector. For the other unit vector, we will first need to find the position vector in direction of the line AO. So let's set up the position vector AO. Well, this vector is going to be negative 1i plus 2j minus 2k. The magnitude for this position vector is going to be it's going to be 3. And now we can find the unit vector in direction of AO. And this unit vector is going to be negative 1 over 3i plus 2 over 3j minus 2 by 3k. So now that we have our two unit vectors, we can move on to the last step, that is, substitute in the values for the two unit vectors in this formula, which is the same as this formula right here, but it's just in a different form. So substitute in the values for the unit vectors and solve for theta. So let's do that. Let's do it on the next page, since there is very little space left on the previous page. Okay, so cos of theta is equal to the first unit vector, that is negative 0.5345 I plus 0.8018 j plus 0.2678 k, and this is dot product with the second unit vector, that is negative 1/3 I plus 2/3 j minus 2/3 k. So now we will use another formula that we discussed in the previous video, and that formula is the first formula that we discussed, which is how to actually do a dot product. So we will be using this formula right here. So in order to solve a dot product, what we have to do is take the product of the respective I, j, and k values and then add those products up. And it's as easy as that. So negative 0.5345 multiplied by negative 1/3 plus 0.8018 multiplied by 2/3 plus 0.2678 multiplied by negative 2/3. Alright, now that we have this number, we can simply take arc cos of both sides, and I'm not going to solve this all these calculations. You can do that yourself, but I'm just going to write down the final value for theta that I got, and that is 68.9 degrees. So this was the procedure for this question. As you noticed, we used two of the formulas that we discussed earlier, the first formula and the second formula. We will be using these formulas again in other questions for this chapters as well. Thank you very much. See you in the next video.